Okay, what I need to do is I need to create for you a second sheet of various calculus notes. And because we got a couple pieces that aren't on there, okay? On the back side of your differentiation sheet, okay, so you got this sheet right here, flip to the back. Yep, on the back side. I don't have a special spot for notes. Not enough hours in a day right now. We got new material. Sorry. Preaching to the choir. Alright. Alright. Anybody know what that is? It means derivative. Everybody okay with that? So what about this? I don't know if you guys remember this, but the inverse sine function, I'm only going to do this once. We spent a little time this last year. You guys were asleep during the lesson, I swear. But if you look at the graph of sine of x, it looks like that, right? What's that? You do? Awesome. Okay. So, here's what happens though, okay? We also have a graph for inverse sine. And inverse sine looks something like that. If you take the inverse of a function, it reflects it over the line y equals x. And you would get this shape all the way around. But is that a function? No. So you would get, this wave that was along the y-axis. But you can't have that. And so what it does is that's no longer a function. So it restricts it so that it is a function. This is what you do. Every time you press sine inverse on your calculator, or tangent inverse, this is a function as well. And these do come up in calculus too. All we want is just look at the forms that are derivatives and use some basic chain rule stuff. It's not very complicated. You guys will do just fine. But we got to write down the rules. And that's an assignment that you're not doing. This is what we want to be at right here. The derivative of sine inverse happens to be 1 over the square root of 1 minus x squared. What's the derivative of cosine of x? Negative sine of x. Derivative of cosine inverse happens to be negative 1 over 1 minus x squared, the square root of that bottom. See how closely they are related? We could prove to you these forms, but I don't have time. What's the derivative of tangent? Secant squared. The derivative of tangent inverse is 1 over 1 plus x squared. You know the derivative of cosecant? Negative cosecant of x tangent of cotangent of x. The antiderivative, or I'm sorry, the derivative of cosecant inverse negative 1 over x times the square root of x squared minus 1. That's what it is. No. Yes. I knew, I'm sorry. Yes, definitely I knew sine, cosine, and tangent. After you use them a lot, you'll... What's the derivative of secant? Yep. Anybody want to guess by our other form what the derivative of secant is? Very good. Positive 1 over x times the square root of x squared minus 1. And the derivative of cotangent, do you remember what that is? Negative cosecant squared. And the derivative of cotangent inverse of x is equal to negative 1 over 1 plus x squared. Got them? All you have to do is get them, and then we just use them. Find the derivative. If you were going to find the derivative of cosine of negative 5x to the third, what rule would you use? The chain. If we're going to find the derivative of cosine inverse of negative 5x to the third, we have to use the chain rule as well. The outermost function is cosine inverse of u. What is u? Negative 5x to the third. What is the derivative of cosine inverse of u? Negative 1 over the square root of 1 minus u squared. What's the derivative of negative 5x to the third? Substitute back in. So negative 15 times the negative 1 would give me positive 15 x squared over the square root of 1 minus. Now I've got to square this u, don't I? No, we got to square. It says u squared, right? So square this. You get 25x to the That's it. Try number 2 on your own. You want to write it like that? No. You gotta square. You gotta square the x to the third as well. Is that the right answer? Is that right? So you can see that this is really actually really not that bad, is it? I have a long explanation for that. You're going to do 3 and 4 on your own tonight. Let's do number 5 together. Then you are in big trouble. Number 5's a little bit more involved. Anybody know what the outermost? Very good. U to the third. The inside is double chain. Very good. Inside is sine inverse of 5x squared. What's the derivative of u to the third? 3u squared. And plug that back in. How do I go about finding the derivative of that? Chain rule again. What's the outside? Sine inverse of u. Inside is 5x squared. What's the derivative of 5x squared? 10x. What's the derivative of sine inverse? 1 over the square root of. So we're going to take this times this, so you get a 10x on top, over the square root of 1 minus square 5x squared. You get 25x to the fourth. Now we got to take this times this and plug that back in, right? So you have 30x on top. On bottom, you have the square root of 1 minus 25x to the fourth and times u squared. So that's going to be times the quantity sine inverse of 5x squared squared. No, plus c is for an antiderivative. This is a derivative. Yeah, you can put the sign on top if you want. That's it. I just want you to do those 5 problems. That's it. That's your assignment. That's your assignment. What? So I want you to do the other 5. So I gave you those 2, 3, 4, 5. Those 5. Okay. That's all I want you to do. The other sheet I gave you is then the antiderivatives. Tomorrow.